Hi everyone, welcome to Netgate Chemistry. So in the previous video, the last topic which we discussed was density of a cubic crystal. So now we are going to discuss the first crystal structure, that is your NaCl. In NaCl, Na positive ions, they occupy all the octahedral voids and your Cl negative ions, they occupy FCC structure. So we are going to show Na positive ions like this and Cl negative like this. So suppose this is a crystal structure. So first we are going to locate the Cl negative ions. Cl negative ions are occupying the FCC, so they will be present at the corners. As well as the face centers, upper face, lower face, left, right, front and back. This is your FCC. Next we are going to show the Na positive ions which will be occupying all the octahedral voids. So where the octahedral voids are present, first it is present at the body center and also at each edge center. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, this is not there. 12 edges at each edge center. It is present at body center also. Na positive is present. So this is basically the structure of NaCl. So we have already discussed how octahedral voids and tetrahedral voids are located. So now it will be easier for you to locate Na positive ions. So now some of the characteristics of this crystal lattice. First is number of Na positive atoms per unit cell. See, one is present at the body center, that will be contributing fully. Next, there are 12 Na positive ions present at each edge center, each contributing 1/4. So if you calculate this, it comes out to be 4. So there are 4 Na positive ions in this unit cell. Second is number of Cl negative per unit cell. See, Cl negative is occupying FCC structure, so it will be present at each corner. 8 atoms are present at each corner, each contributing 1/8, and also 6 are present at face centers and each face center contributes 1/2. So it also comes out to be 4. So there are 4 Na positive and 4 Cl negative per unit cell. Third is total number of total ions per unit cell. That will be equal to 4 plus 4, 8. Next is your formula per unit cell. That is also 8/2. 8 is number of ions present, and 2 is the number of ions which are present in the formula, so it comes out to be 4. Next is the structure of cesium chloride. In cesium chloride, Cs positive is present at the body center and Cl negative occupies all the corners, basically SCC. So if you want to make a unit cell of CsCl, in CsCl, Cs positive occupies body center and Cl negative occupies SCC structure. So if this is your unit cell, we are showing Cs positive like this and Cl negative like this. So Cl negative will be present at the corners like this, and Cs positive will be present at the body center here. So this is the structure of CsCl. Now the characteristics. Number of Cs positive per unit cell, that will be equal to 1 because only one Cs is present which is contributing fully. Second is number of Cl negative present per unit cell. There are 8 Cl negative present and each contributing 1 by 8, so it is also 1. Formula per unit cell, that will be equal to 1 divided by 1, that is 1. The coordination number. Cs positive is having coordination number 8 and Cl negative is having coordination number 8. Okay, in case of NaCl we have not discussed coordination number. So in case of NaCl, the coordination number of Na positive is 6 and Cl negative is also 6. Okay, now we'll move on to the third case, which is your perovskite structure. That is CaTiO3. In this case, Ca2 positive is present at the body center, Ti4 positive is present at the corners, and O negative is present at each edge center. We'll represent Ca2 positive like this, Ti4 positive like this, and O negative like this. So suppose this is the unit cell. So now Ca2 positive is present at the body center like this. Ti4 positive is present at the corners. And O negative is present at each edge center like this. So this will be the structure of your CaTiO3 or the perovskite structure. So now the characteristics. First, number of O negative per unit cell, that will be equal to 1 by 4 into 12, that is 3, because we know there are 12 O negative present at each edge center, each contributing 1 by 4. Next is your number of Ti4 positive present per unit cell, that will be equal to See, they are present at 8 corners, each contributing 1 by 8, that is 1. Third is your number of Ca2 positive present per unit cell, that is 1, which is present at the body center. So total number of ions present per unit cell will be equal to 3 plus 1 4 plus 1 5. So formula per unit cell, will be equal to this total 5 divided by 3 4 5, that is 1. Now coordination number. Coordination number of Ca2 positive is 12. It is surrounded by O2 negative ions. Next is your Ti4 positive. It is 6, surrounded by O2 negative ions, and O2 negative, which is surrounded by 2 Ti4 positive. Sorry, here is O2 negative. So this is all about perovskite structure. So next is the structure of CaF2. So in CaF2, Ca2 positive is occupying the FCC lattice, and F negative occupies all the tetrahedral voids. So I think this will be clear. The picture will be clear to you. Ca2 positive will be having FCC, that is, it will be present at the corners and also at the face centers, and F negative will be occupying all the tetrahedral voids, which we have discussed how tetrahedral voids are present. So I'm directly going on to the characteristics. First is number of Ca2 positive per unit cell, that will be equal to, see, Ca2 positive is occupying FCC, so 8 atoms will be present at corner, each contributing 1 by 8, plus 6 atoms will be at the face center, each contributing 1 by 2, so it comes out to be 4. Second is number of F negative per unit cell. So I have told you any atom present in the tetrahedral void contributes fully, because tetrahedral voids are present as a whole inside the unit cell. So it will be equal to 8, because there are total 8 tetrahedral voids. Next is coordination number. For Ca2 positive it is 8. For F negative it is 4, because it is present in tetrahedral voids, so definitely it is going to have coordination number 4, and because it is occupying FCC, so it is having coordination number of 8. So fourth is total number of atoms per unit cell, that will be equal to 8 plus 4, that is 12. Fifth is your formula per unit cell, that will be equal to total 12 divided by atoms in the formula, 2 plus 1 3, 3 4s are 12, so it is 4. So last structure of today, that is Na2O. These are also called fluorite and antifluorite structures. So in Na2O, Na positive occupies all the tetrahedral voids. This is just inverse of this, and O2 negative occupies all the FCC structure. So here also number of Na positive per unit cell, that will be equal to, it is occupying all the tetrahedral voids. There are 8 tetrahedral voids, so it will be 8. Second is number of O2 negative per unit cell, that will be equal to, see, it is occupying FCC, so same as Ca2 positive, 1 by 8 into 8 plus 1 by 2 into 6 comes out to be 4. This is just inverse of this one. Now coordination number will also be inverse. Coordination number of Na positive will be 4 and O2 negative will be equal to 8. Total number of atoms will be 12. Formula per unit cell will also be the same. Okay, so in the next video we are going to discuss about the beta cristobalite structure and the zinc blend structure, and then we'll carry on with the other topics as well. So I think that's it for this video. Thank you so much for watching.